Good day, everyone. My name is Enrico. I'm co-head of VFX at Milk, as you probably have read already. Thank you, and thank you Side Effects for having me. It's a real pleasure to present to you some of our work. Today, we're going to talk about how we build and rebuild USD and Milk and how we tend to break them. It's a packed kind of talk, so I will try to make it in time. But yeah, let's get started. So a little bit about Milk. Milk has been around and for quite some time, has been a London-based VFX studio since its founding in 2013. However, recently we have expanded in our European footprint, and we're now outposts in Dublin, Bordeaux, and Barcelona. It doesn't end there. Since October 2025, we have officially become part of the Phantom Media Group, PMG, which includes alongside us studios of the likes of Phantom FX, Lola, which is our sister company in London, and the historic and iconic Tippett studio, and Spectre's Post as well. So as you can appreciate for the map, it's become quite busy, which is quite exciting in terms of the deep level of integration and collaboration we are achieving. So we are focused on maintaining distinct creative identity across our regions, which are now North America, UK and Europe, and the Pacific Asia. So regarding Milk, we are mostly focused on environment type of work, creature work. We do the whole pipeline, but mostly for film, episodics, and real-time and immersive experiences. This is our latest portfolio of projects, which includes 3 of the projects we're gonna use to look at specifically how we introduced USD in our Houdini Solaris pipeline. One of them is Rats, a Witcher story, which we worked on 2023, 2024, Heads of State, which we work on 2024 and 25, and lastly, Lockerbie, the bombing on Pan Am 103 in 2025. It was a deeply humbling movie to work on for us, and an unfortunate real story. So just to warm you up, let's have a look at our house reel. Thank you. So a little bit of an agenda of what we're going to talk about today. So how we approach USD, or we were forced to approach USD, the RATS experience, which we use an experimental platform for much bigger things to come, a parallel ecosystem for compartmentalized linear. Basically, from a compartmentalized linear USD caches used to a pipeline step driven recipe. Department alignment, a couple of lessons learned. The head of state as a full implementation of the backend pipeline we came up with, and how we are now evolving into more environment-based assemblies using the Lockerbie experience. You are all very familiar with the Alembic and VFX pipe and FBX, not FMX, FBX pipelines, which still remains essential to Milk for various purposes, including legacy workflows and many practical needs from rigging, animation, and Unreal, especially when it comes to FBX. Alembic and FBX offer a lot of efficient and hierarchical data representation, but it's just basically a static snapshot. And it does force us to do a lot of stitching in terms of pipeline, and we decided to shift to USD because of the claim of a parallel, non-destructive workflow, which sounds like Photoshop, but is much bigger than that. So we wanted to abandon the idea of linear and stitching type of pipeline. This is a graph that is probably as boring as it looks like, but is really where we were in 2022, 2023. Very linear, very Alembic and SSS based for rendering descriptions. It revolved around those files and the rest of the BGOs and VDBs, which are still there, but now they are more part of how we write the recipe via USD. This is kind of the mindset that we are trying to have in the new development. It wasn't just another way to store data for us, which, by the way, is not the most efficient way to store data when it comes to USD. USD is designed for dynamic composition. It's not about heavy caches, it's about instructing the heavy caches, how they're built. And we have a look at that. It doesn't just, as mentioned, store data, it stores a recipe for how that data is assembled. And that's, I would say, is the fun part, alongside the procedural workflow in Houdini. So we need to be able to alter that recipe at any step of the pipeline. And we're trying to find a true vertical parallel workflow rather than a horizontal workflow. So to use the RATS project experience, as mentioned, the RATS became an experimental platform for us. The show had different requirements. Basically magical effects, environment and DMP set extension, multiple building and props, but most importantly, the creature, the hero creature, which was called Jallowick, was the hero which we use to revolve around our new toolset. In 2023 and 2024, we're going to do a creature-based. We knew that we were going to do multiple creature-based driven projects, and this was the perfect place to start nailing down predictability and rewrite our built infrastructure. So this is the main creature that we developed originally in-house and conceptualized. So it was a mix of flash, rotten flash, bones, the two things behind the back that we called wings, extra arms, blades, arms. We didn't create a muscle structure underneath, as it was anatomically too convoluted. So we had specific located soft tissue simulation for the cloth and for the joint parts. Patches on the chest and so on and so forth. Although, as you can imagine, the main challenge was the body tracking and the rotomation, especially because the actress and the stunt had some extra prosthetic on the arms, which we needed to replicate via the scan and provide to the rig as well for rotomation and inform later on the movement of the arms for the animators. Anyway, in terms of USD, we came up with these tools. This is what we call the SG import, and it's the assembly tool around which layer collection, as in assets and shot elements, happens in Solaris. It uses ShotGrid to sublayer or reference caches into the stage, Houdini stage, in an additive type of fashion, so in a vertical additive type of fashion. It queries ShotGrid for assets and shots data, publishes, depending on the queries criteria you give to it. Is it kind of readable? Hope so. So it just reads all the local variable of the shots, and then it goes and finds what is published and or approved. So it stacks up very simply like that. We have the asset coming in, the base access, we have the look dev attached to it, and then in an additive fashion inherits from the animation and all the other layers. So it wasn't as simple as that, but this is fundamentally the principle. Basically, then after this, obviously you attach the CFX path, the shot sculpt, the groom, and so on. And it doesn't bring in any new cache. All it does is reading what's happening to the asset. It just reads the transformation and the vertex information from the animation cache. And therefore, the scene, which is also referenced, is very light. It worked well for us once structured. It does let the user know when a newer version within the established criteria is available. But it's not easily scalable, as you can imagine. So it needs high user management. However, its principles still would constitute what we do expand later on. Just want to give you a breakdown and a break as well from this information, showing you a little bit of a breakdown from the rats. I'm back, okay. So the problem is when we had to jump from the specific RAS project to another project I won't be able to talk about because it's not released yet. But it was an 8-episode docu-series with 70 plus asset creatures and variants. We couldn't really handle it with that kind of system, so we really needed to dive into... That project, by the way, is going to be discussed at SIGGRAPH this year, so if you happen to be there, go and see Hisan, the VFX supervisor, on that one. We needed to dive into USD concepts like stage, Houdini stage in terms of the root layer that established the root hierarchy, layers and sublayers, references, payloads, inherits, overrides, instancing value clips and specializers as well. So we wrap all this concept around this specific system. we didn't come up overnight with this. Is a constant evolution, but basically stemming from the ShotGrid querying that we discussed previously and using ShotGrid effectively as a database, we created a two-block asset and shot management system. This is the first block. So the first block is using SG as a database. Anything that is published as USD can be casted. That's the API that you can see on the right-hand side. And this is very much CG supervision work. What we're doing with the casting, we gather everything that is published in order to, according to a default hierarchical pipeline step, which is the left-hand side, represented as such. It's not the only way to organize the hierarchy, but we thought to keep that for simplicity, also in understanding with production and the rest of the department. Every publication is linked to the task, and that task is ordered against the pipeline step. What we're doing is creating a template, like a placeholder. We're looking at a file, we know what needs to go in. It's multiple creature. They're going to be fed in the animation in the respective department, and once ready, they're going to take that place in that recipe. So the API that you see on the right-hand side, we call it MBrew, and it's a tool we use to access all milk brewery, we call it. We use it to access this published information, and we cast it for the shot. We're not casting any version or anything like that. It's just, again, creating that placeholder. MBrew effectively creates a JSON dictionary or description, which is stored and coded in ShotGrid as an attribute entity, and it lives there. Then the second block is another API, but this happens in Houdini, and we'll take a look at it after this. So it's the same for every DCCs, Houdini, Maya, and any QC tool. In the first step, what we call the MilkShot pile, it queries SG publishes and lists them in the Houdini Solaris graph. The second step, the layer editing attribute, is where the artist or the supervisor is able to create rules for what needs to be filtered. Most specifically, also the type of status, available status, work in progress status, or things like that. And the last bit, perhaps the most important, is the one that builds the scene, which is the publishes and layering resolver. We call it MilkShot pop. For the resolution of the published layers, it reads the cast description that we created previously, understand which status is to be considered according to the edit, and then it takes all the relevant attributes that there are in the versions and start piling them up, create a hierarchy. So to give you a look at this is how it looks in Houdini. This is the assembly and likely template that we have, and it's fully customizable. The top part is the shot build part, and in the middle you can create a lighting setup. So in the blue backdrop box, you will see that there is a milk shot pile, a pile edit, and a shot pop. So we're gonna have a run through now. Let's see if I can keep up with the video that I created. So when open the shot manager, we can select the shot we want to work on and then add all the selected shots. The multi-shot menu then allows you to display the whatever shot you want, and we can build the template. The shot pile retrieves all the available information for the shot you have added and creates an effective list of all the version available. We have caps for the amount of version, and of course we're not going to list anything that is declined. In the scene graph, different layers are displayed. One of the shots is added to the list, and another for assets that belongs to those shots. These are all common shots because it's the same sequence, common assets, sorry. The shots pile, so each and every shot has its own cast, which includes all associated elements such as asset, cameras, and all the rest. When you trigger shot pop, it loads all the assets that are relevant to the specific shot that you have selected in the multi-shot workflow. And then you can switch shots automatically, and it updates automatically with whatever was casted. And then you can start doing your editing, you can start filtering for the sequence or for the specific group of shots that were established. This is all in line with the multi-shot workflow. The shot pile edit allows to enable and disable primitives according to the custom criteria any supervisor or any department supervisor needs. It's not something that is visible to artists. This is established at supervision level. And then another useful feature is the ability to filter which version of an asset is loaded. You can load only the latest approved version or the latest version alone if approval is yet to come. Then we have a tool once the edit is completed, or at least the structure is available, which is the shot switch. The shot switch creates a branch for each shot in the list. Additional shots are added later. You can create as many as you like. So it can be even 10 or 20 of the same concept, and you can add it to the switch. When the shot is activated, its branch shows from green to red, and you know which one is available. So then you can start working on your general sequence lighting above the hierarchy, and in each and every branch, you can then work on the specific details of the shot, if you have any. So, let's see. When enabling the live render, it displays all the casted assets and shot requirements or prims with the respective look dev. And then you can switch shots automatically, and it updates automatically. All of this goes in line with the multi-shot works that is behind. So whatever we set up here and we send it to the farm, all of the shotting are going to go rendered at the same time, and every proxy folder will be created from the master shot in each and every, let's call it, client shot. Here's a couple of examples of editing and adjustment that can be done per branch. Okay, so this is kind of the infrastructure. Just a few hints about what this entails in terms of the departments. So obviously, besides this baseline pipeline, we needed to adjust all the different departments in terms of publishing specific department requirements and make them available to the casting and pipeline step hierarchy. So Surviving Earth, this project I told you before, had intensive creature work, as you may imagine, as well as crowd. Those two departments were among the first to integrate within our USD infrastructure. We won't dive into department specifics. I just wanted to share a couple of takeaways we learned a little bit the hard way. As part of USD workflow, implementation, every department have steps created to and added to their respective export template. One step is called the sanitized LOP, and the second step is called the ingest LOP, and they are interchangeable. They work together for the Groom to create a structure of Groom, beauty, proxy, and guides. One thing we found out in Creature is that we didn't really consider properly early that shot frame ranges. But when we started working on Surviving Earth with very long scenes, we were caching Groom on Surviving Earth with some longer frames ranges. We found that output USD caches was very heavy, and the file was simply too big to manage. So a solution we found was to use the configure SOP node before caching and setting attributes that didn't need evaluation on each frame to default. So it helps speed up cache time and file size. This is an example of the work that the creature team has put in place as an example of all the different layers that creature has developed, from muscle, skeleton, tissues, Groom, all the way to this final beautiful result. Crowd-wise, a similar thing. Crowd-wise is relatively complicated, but it's the place where we started implementing value clips. In our crowd workflow, as just a bit of information, we tend to create not just one agent, but two agents, both in SOPs and in LOPs. The SOPs part is the one that we use for simulation. The LOPs part is the one that we use for casting. And the LOPs part is done in USD. So here's a detailed view of how we handle the publishing in Houdini. It's fairly traditional when it comes to SOP. We go to LOPs for the publishing of the... we go to TOPs for the publishing of LOPs. And create our casting elements. But the main highlight is that from crowd, given the complexity and size of the caches, we start implementing the concept of value clips to handle time-varying data. Stuffing a massive animation into one giant USD wasn't an option, because that's not what USD is for. But it allows you to create a stitched version of the simulation, which is instructed then at render time on what are the dependencies. So after crowd, we have implemented a ROP solution integrating value clips for all departments that deals with time varying data, which creates the stitch USD sequence, the manifest USD, and the template USD, which is what we load, cast, and render from. This is one of the main R&D tests that we did early on for Head of State, which was the first project we implemented this workflow on. And this is a fairly quick breakdown of this project. Was a lot of tomato. And it's for another conference. So a final look at some developments regarding environment and how we're expanding from the base pipeline that we discussed. And this is Lockerbie. And this is a project that pushed us into environment. For us, 2025 has been, compared to 2023 and 2024, it was very much about creature, was very much about environment extension, large-scale environment extension. This is a project that required extensive ones. While working on the rats, we realized how crucial it was for us to be able to source a large amount of assets quickly within a library system. So we needed to implement a proper system that would allow us not only for fast processing of data, but that comes with built-in function to meet our environment task needs, which are very dynamic and always changing. So let's have a look at this one. So we start with a Houdini implementation called Environment Asset Compose to source library assets directly in Houdini. Today we go for graphs. We have a composition arc control that to manage how the asset gets composed and loaded on the stage level, as well as associated variants. There is an easy variant selection, so we can see what is available at glance. And basically the system integrates also Copernicus for doing and manipulating textures in Houdini directly. And that is a fetch equally shaders management bundle, so we can easily give the asset the tweaks that it needs. So we can edit our library elements, and then we'll see later how to import it. On top of that, texture resolution controls as well, because as many of you know, is very important for fast pre-visualization, but also we don't really need high resolution texture for stuff that is far in the background, so that flexibility. Once all the criteria are established, then the asset can be imported into the project and becomes unique to the project and doesn't affect or destroy the library, which remains intact. And finally, we can also bridge between SOPs and LOPs, all to be able to edit and use both potential functionality. There is fundamentally a replica in SOPs of what we have just seen in LOPs, and we can create multiple versions of that same library and then again re-export it back to LOPs. You can see that there is the same UI to import the same library into SOP level as well, and then we can re-export it back into LOPs whenever we are happy. Lastly, basically what we wanted to do after this, we were interested in layering, basically opening the graph to the artist and make it editable, and not just the end part of the process, but the starting point of the process. So rather than pulling assets to a graph in a rigid way, we wanted to reverse engineer the process and start from the graph itself. Each artist could author or target some primitives and bring appropriate layer stacks. So this is how it works. We start by creating let me kick it. So we start by creating a manifest or a template of what the graph structure will be for the asset. And this process is actually very helpful because an environment usually holds hundreds, if not thousands of primitives. And this steps makes you really think about the full extent of what's ahead of you. The highlight is our layer manager system that makes the whole system come to life. Basically, what you are seeing is in the viewport is the asset we created for Lockerbie, which is quite heavy with a lot of small elements in it. So the layering system itself gets managed from this panel, which essentially creates a mirror of the graph and allows for dynamic primitive loading. As you will see, the structure is exactly identical. This is the panel that I was referring to, and just fundamentally replicate the Solaris graph, and allows you for editing the graph and extract whichever primitive you want to work on. Then loading primitives get as simple as that. You can bring in elements, you can get as granular as you want by accessing primitives further down the hierarchy, if you need to do so. All of this gets done from a graph standpoint, and the primitives become the root of everything, rather than being the end of the game, the end of the line. So we think this is quite powerful for building more assemblies on a shot basis, for example, rather than carrying the one big asset that takes a toll on your whole system, and having to prune things downstream. Instead, we kind of rebuild it at needs, besides the major infrastructure assembly that we have. Okay, so one more example of what we were able to achieve with this set. And if you allow me, I would just take a chance to, before playing, I would like to dedicate it to the amazing Kieran Crawley. He is the VFX supervisor that did this project, and that unfortunately passed away very recently. And I want to thank him for all he's done for Milk, and I just want to remember him with this breakdown. And thank you.
We're definitely tight on time, but we've got room for maybe 1 or 2 questions. Yeah.
Thanks for the presentation. Did you even try to store USD information in a layer of rigging, or?
No, not exactly. We do export rigging descriptions for crowd because we need to inherit the animation or the clips. But no, we haven't done. That's one of the part that we haven't done. We're still working with within Maya scene templates to inherit in the animation template. So we haven't yet.
Any other
We are trying to start animating in Houdini, that's for sure.
Love it. One more, maybe. All good? Good. Thanks so much.
All right.
Great
Thank you very much.